Hello and welcome to this video on how to deploy the BBAT tool. BBAT is a GIS-based behavior observation and mapping tool. During the observations, locations of every person that's being recorded is marked on a map, but also some additional data is collected. The social background, also the gender and age, and primary activity that the person is engaged in, and secondary activities. The resulting dataset is a cloud of points that can be inspected visually. Already looking at the map, you can see areas where people are more frequent and areas that are less frequented by users. But also you can apply more elaborate statistical analysis and go into, for instance, geographical analysis, hotspot analysis by age, for instance, how different age groups use the area. You can also analyze the attribute table, for instance, look at the proportions of different activities, or proportions of whether people are using the area alone, in pairs or in groups. All sorts of percentages can be calculated. And it's pretty straightforward. If the word GIS puts you off, then actually it's not very complicated. GIS is just a tool and you can learn it, and it's not hard. I hope that this video will also demonstrate to you how easy it is to start with it. Second, I'd like to draw the parallel between BBAT and another observation tool, SOARC. BBAT is compatible with SOARC. So if you're familiar with the SOARC method and analysis of that data that's been gathered with SOARC, then BBAT can be converted into the data that you obtain with BBAT can actually be converted into SOARC format. So you can compare different areas, or you can use different observation methods for different times or periods and compare the data. Well, what do you actually need in order to deploy the BBAT observation tool? First of all, you will need a tablet computer, and things that you need to consider when looking for the computer is screen brightness. I think it's the most important factor, because while doing the observations in bright sunlight, you really want to be able to see what's on your screen. So look for screen brightnesses of 400 nits and above. Secondly, you also want to probably at least acquire a stylus, which is an electronic pen. It's a precision pointing tool that you can use to pinpoint exactly where you want to place the dot that represents the location of a person. Then you're doing field work for quite a long time. We've also had observations running for 4 hours, for instance. So weight is an issue. Every gram counts. Lastly, there are different operating systems. We suggest that you use Windows. Then you will need to download and install QGIS software. It's a freeware, and you can find the download link on this address. BBAT was developed on QGIS version 2.18.7, but I'm pretty sure that the latest and greatest version will also support the package that you will download. The package BBAT files are located on the same website. You can download them as one zip file. Everything is in there. We've provided you in this package with also some maps, but of course you will need to get hold of the maps of the area that you're about to analyze. And these maps can be AutoCAD files or raster images as well, but you need to do some extra work to get them into the GIS. So preferably ask for Esri shapefiles and GeoTIFF format raster images. Then you will also need to decide on the observation schedule, how often you want to do the observations. Of course, you can already get some feeling from just one observation campaign, but to get a fuller picture, you might want to do observations in different times within the day, on weekends and work days, and also incorporate some time in between, so weather changes and you get some good weather and bad weather data. Lastly, you also need to think about backup, just in case it rains. What we ended up doing is carrying a transparent plastic bag in the pocket. So when it started to rain, we would put this around the tablet, and it was actually quite okay to work with the tablet wrapped in transparent plastic bag in pouring rain. Another option is that you prepare a paper version of the BBAT. You can use this in situations when the battery runs out, or for instance when you don't want to be seen hanging around with the electronic gadget, so areas where safety is an issue. Then paper version of this tool can also be helpful. Here's an example of the paper form that is being used in our case. You can of course invent your own symbology. We opted for writing codes instead of inventing different triangles, circles and crosses for all these different activities. But of course you can do that. Key to this code, I'll explain briefly. F means female, 3 means age group, GR is for group, 3 people in the same location. The activity, the primary activity, is A1, which is lying down, and secondary activities are 2 and 8, sunbathing and chatting. Enough of the introduction, let's get to it. So, Here is the zip file that contains the BBAT tool. You will need to extract those 3 folders. It usually makes sense to move the folders further. You can keep the observations folder on desktop because it's rather convenient to launch the BBAT from the desktop. However, the maps and some data that you've acquired, those don't have to be on the same location. You can bury them deeper in the folder structure. That way it's not giving you clutter, and also it's less likely to be moved, deleted, changed by accident. Okay. So what's inside those 3 folders? Well, pretty obvious. Maps is maps. We've provided one demo area in Tallinn, Estonia. It's covered in aerial imagery and some vector-based maps as well. And then we have also included a global map that covers the whole globe. That's just background purpose, and it's hopefully going to help you making sure that when you plug in the map for your area, it actually is in the right location on the globe. Right. Sample data, we've included incomplete observation data from 4 observations. One of this reason that I'm showing this folder is because of the naming convention. Every observation will be in a separate folder. So basically you take the seed folder, we call it, and make copy of it and rename it accordingly. So the naming convention, of course, you don't have to follow it. It's just a matter of convenience. First is the site name, then the year, month, day, and then time within the day, and then the surveyor that was doing this observation. That's good for tracking purposes when you are allocating salary money, for instance. Right. So, observations. That's the folder where the BBAT tool itself is actually located. We've included a blank paper form for you. And the seed folder for Tallinn. The first thing is, let's make a copy of it. And rename it to demo. The year is 2020. Then that's it. Let's go inside. Right. It's quite a lot of files, but actually the components here are not so numerous. All of these files are associated with the weather data that you will be entering in the beginning of the observation. That way you can also make queries like show me only users that were recorded in rain and temperature below 15 degrees centigrade, for instance. So all of that is for the environmental conditions file. These are all files that are necessary to gather the data itself. So the points are recorded in the shapefile, and all the attributes that are collected, like the activity, the primary activity, the secondary activity, and gender and age group and all that. That's in the DBF file. And actually you can open that DBF file with OpenOffice software and convert it to Excel file, for instance. Lastly, there's activity type CSV. This is a file that contains the list of activities that are shown in the menus. So if you want to alter the BBAT tool to your needs, for instance, if you want to add golfing, we don't have golfing in the tool programmed, but you can change that here. So if you open the CSV file, you'll be able to add features to different submenus. The tool itself, or the container that launches the BBAT, is QGS file. So if you have QGIS installed already, double-clicking on QGS file will launch the program and load everything. Right. You may be greeted with this very ominous window that says handle bad layers. Basically, QGIS is saying that I cannot find some files. And these are mostly related to the maps that we've included. Not a big issue, just select them. And this is raster, so that's aerial imagery. So just need to find the aerial imagery. Maps, aerial, provide the folder, select, apply, and these are taken away. The rest is still red, so let's select everything. Browse for the vector maps. Select folder, apply. Still a couple remain. These are the global maps. Let's browse. Stop. Maps and global. Apply. Nothing left. Okay. So every installation of the program usually defaults to some sort of menus and toolbars that the programmers think are necessary. So the first thing is customization of the work area. If you go to View menu, and on the bottom there's Panels. What you want to have selected or turned on is Layers panel and a toolbox. The toolbox, that's over here, that one. You don't need it later when you're doing the fieldwork itself, but during the preparation and also during the analysis of the files, you may find that helpful. Toolbars. You want to turn on Attributes toolbar, Digitizing toolbar, Manage Layers toolbar, Map Navigation toolbar, and Project toolbar. And out of these toolbars, later on when you're doing the field work, you actually don't need the Manage Layers toolbar, and you can also turn off the Project toolbar. but let's have them on for now because we're not in the fieldwork phase yet. Also, something that's often helpful, but in our case not, is snapping. Snapping is basically an aid that moves the point that you clicked on the screen to some sort of object nearby, so you can snap to different points or corners that are nearby the area where you actually clicked. Often very helpful, but in our case actually counterproductive. Settings, snapping options, and you need to make sure that snap to is in off position. If you have a mouse, then you can use the scroll wheel, but out in the field, if you want to move the map and zoom in, then on top we've turned on these panels already, so you can use plus and click or tap with the stylus. Here with mouse I can also do drag a window and scroll with the scroll wheel. You will not have that luxury in the field when you want to have less equipment on you. Right. Now QGIS is able to display very many files at the same time together. All of these vector-based objects are loaded in separate files. So if you untoggle this group, you can see a whole bunch of files. Every single one is a separate shapefile. These shapefiles are in different projections, and for the universality of this tutorial, we've kicked off in universal projection mode. But once you have zoomed in to the location that you are working with, then it makes sense to actually change that squished projection into something that is appropriate for your country. You can search for the projections. EPSG is the term that you're looking for. So EPSG and your country name. Google it. Okay, now it's more manageable. Right. Let's also open up the orthophoto group. You can add vector layers by selecting this button, add vector layer, browsing to the folder where your vector layers are located, and just selecting them all and then clicking open. I'm not going to do that now because I already have the same files loaded already here. But basically when you click open, it will load them. QGIS will automatically assign some sort of random color and line to every layer, and of course you can change that. So for instance, let's change the power line. If you double click on this layer, you can start changing the display properties for that specific shapefile. So you can change the color, transparency or opacity. Here's another transparency that affects the whole layer. Sometimes if you choose different graphic styles, you can alter that. For instance, the bounding edges are not transparent, and then the filling is transparent. So two places where you can alter the transparency. You can also alter the thickness of the line. So that's helpful in creating your map layout. You can see that some of these shapefiles have line and some seem to have a polygon. So these are separate file types. So polygons, lines and points is the domain of Esri shapefiles. The orthophoto in the background is also something that you can add. If you get hold of GeoTIFF format, then all you do is add them without referencing, because GeoTIFF already has the projection and location attached to the image. So add raster, and browse to the folder where the files are, select them, either one or all of them, and open. You can also alter the appearance of these images. Again, if you double click, it's possible to change the brightness level, contrast, and you can also colorize. So all sorts of manipulations that you can do to the orthophoto. Let's just demonstrate what happens if I click OK. So that tile over here, that's the original color, as it were. Sorry, I forgot to turn off the colorization. So that's the original orthophoto. Rather dark. When you're working in the field in bright sunlight, that could be an issue. So that's the reason why you want to test out what sort of levels are workable for you. Excuse me. So let's get back to the original. Colorize 40 and 40. Okay. The stack of these layers is drawn in the same order as you can see on this layer panel. So sometimes it may happen that you load the data, for instance the points that you have acquired, and it happens that it's below the orthophoto, and you will not see that data. If you move it above the orthophoto, the points are here. So the order of these layers is something that you also can pay attention to, or you need to pay attention to. So you can also control the visual appearance of the map by just rearranging the layers. All right. Let's collapse the groups. And also turn off the sample data because it's sort of later phase. So once you have prepared your seed, you've imported all the maps, you made sure that the maps are actually workable in the bright daylight, then you can save that composition. That project is saved with that button. Why I'm talking about this is that you can also see some other save buttons. For instance, there's a save button here as well. And that's also a source of some confusion. And this is the reason why I also suggest that when you go to fieldwork, you actually turn off the project toolbar. The project toolbar is for the, let's turn it back on. Is for arrangement of these layers. So arrangement, the color manipulations, the order in the stack, all that needs to be saved somehow. And that is saved in the QGS file. So when you're pressing that save button here, that just saves that file, the container file, not the data itself. It's an assembly, and we're saving the appearance of this assembly. I'll come back to this concept in just a moment. It appears that we have finished with setting up the seed, so we can close that program, and now we can treat this one as this folder as the seed that we can work on. So let's make a copy of this folder, and every observation needs to be placed in a separate folder. So make a copy, delete the seed prefix. Instead of demo, you will have your site name. Then today is June 18th. So 06 and 18. And let's say it's early morning. So morning. And you can add also your name. That way you can also have two observers running around the large observation area, collecting the data in parallel, and then later you can merge these two files or two folders together. So once the copy has been done, go in there and launch the QGS file. Right. I'll also turn off the global map. You can actually do that in the seed. That way you don't load the computer too much. So let's do some sample observations. We zoom into the area, and first we need to collect some weather data. So the reason for collecting the weather data in the beginning is that the numbers that we insert here in this first layer will automatically get copied to the behavior data that we're collecting. So every single point will also have the weather parameters attached to it. So that's the reason why we start with conditions layer. The conditions layer is a shapefile. All of these files are in locked position, which means you cannot actually by accident do something to the file. You also need to tell QGIS that I really want to change that file. So you need to turn on the edit mode. This pencil is the tool that you need to turn on. And now the layer becomes editable. And you want to add a point. So that button here. You can add that point anywhere because it's actually not that relevant where you register the weather. So let's click somewhere outside. Okay, now we're presented with something that looks slightly weird. I haven't told you yet. Different computers have different resolutions on the screen, and we've actually provided that BBAT tool with 2 different resolutions for the data forms. I'll show you in a minute how to change that. At the moment, the form, the data collection form, is way too large and it's very sparse. So that's because it's a wrong interface file that was loaded by default. But bear with me for now. The first thing that you do is the conditions. You want to state the observation date. You can scroll that to June 18th. Is it weekday or weekend? Say it's weekday. Time of the day is morning. Let's pretend. The air temperature in closest available weather station, it defaults to 20, and you can scroll and also use the keyboard, but in the field with the tablet computer it's much easier to just click on the screen and scroll until you have the right number. Cloud conditions: clear or few clouds, considerably cloudy, almost or completely overcast. Let's pretend it's clear or few clouds. Precipitation: well, if it's clear then it's dry, but you have options of light rain, light snow and heavy snow. The wind conditions, also something that you need to judge when you're out in the field. Is it calm, breezy or strong wind? Let's say it's calm. Water surface conditions, you can add frozen over, or if it's not ice covered then it's calm water, mild waves or strong waves. This is somewhat subjective evaluations that you're having here, so you may want to discuss with the observers and train them on what you think is calm water or mild waves or strong waves, just to unify the judgments. Water level in cases of high and low tide, that's relevant, but for instance with lakes that's not relevant. Also with the case of Baltic Sea, tides are not really an issue, so unknown or not applicable is also perfectly okay. And there is comment box, so you can use text to describe some extra comments that you want to add. It's not mandatory. So once you've entered that data and press OK, then the point is created. However, it has not been saved yet. So if you were to close this program, you would lose the data. Every single shapefile is a separate file, and changes to those files, in our case the conditions, need to be saved. So that's where this save button comes in. Save layer edits is not the same as this big save button. So save layer edits, and you can turn off the edit mode. That way you've locked the shapefile. And you can see the attribute table, so the data that you have just entered is here. And that data will also be copied to the points that you are entering. So let's describe some further steps. You're doing the observations, you come to a location where you stand, maybe you want to seek shelter, the shade, so that it's easier to see what's on your screen. And then you observe a certain area. You cannot observe the whole area from one location usually, unless the area is very large, very small. If the area has any size to it, you will definitely have more than one observation spot. You want to be rather consistent in doing the observations from the same observation spots. So it's very important that once you're in the observation spot, you visualize what area you are covering. So if you're covering this grass patch, then you need to remember that you have observed that area already. So when you're in the next observation spot, let's say it's somewhere here, you don't cover that area again. The observations are done from left to right. You make a 360-degree turn, and you can subdivide the scanning field into pizza slices. And if there's a lot of people, you can narrow down the pizza slices, so you are reducing your workload. You cannot remember 10 people at the same time, what they were doing, what age group they were in, and so on. So you need to break down the large complex problem into smaller units that you can handle. Right, let's do some demo points. So the behavior data is in behavior data shapefile. Turn on the edit mode, and you start adding points. Add feature. So let's say there's a goalkeeper somewhere here. Right. Let's say that it's male, teenager, because it's a football game, then it's a group. And the activities, you can have one primary activity. It takes time to memorize all these different options that you have, and I also described that you can actually change what's displayed in the drop-down menu. This activity types CSV file, that's what defines these drop-down menus. So it's the football game is in sports and games, so ball games, alone and teams together. And maybe that person is also drinking a soda while waiting for the game to come to the location where he is at. You can have many secondary activities, so you can check them all. Of course, it's not realistic, but it's possible to add very many secondary activities as well. So when you click OK, that person data is stored in that location. It hasn't been saved yet. Let's add another point, another goalkeeper. Let's say it's a girl, and it's a group activity, ball games, and there's nothing else that she's doing, so that's okay. And let's add 2 players with ball on that side. Click. Let's say the players are older, so adults. Adult female in a group, ball games, okay, and another player there, which is male adults in a group, ball games. Okay, right. So we've added 4 points. They haven't been saved yet. So save the layer edits. And if that's all that you have here, no more points, then you also turn off the edit mode and walk to the next observation spot. You come to the next observation spot, turn on the edit mode, and start clicking again. So that's basically it. You cover the whole area with different observations, and if you look at the time slots, they are 4-hour time slots. So if you're dealing with very large areas and you expect to have very many visitors to the area, then it makes sense to split the area geographically into smaller parts and have more than one observer covering the area. Okay, I said that actually you don't need some of the toolbars. So the toolbars that may cause you confusion, so people thinking that when they press the save button they're saving the data that they have entered, and then accidentally closing without actually saving the shapefile. So in order to avoid that confusion, that has happened to us a couple of times, you can go to View, Toolbars, and disable the project toolbar. That way you have less confusion. And also you don't need the layers management. So that gives you more screen space, and also the processing toolbar, even more screen space. And eventually, when you're really good at it, you can also sort of undock this layers panel and win even more screen space for your map. So out in the field, having a large map, the whole screen covered with the observation area map, is sometimes very, very helpful. Especially if you're looking for landmarks that help you identify the actual location. It may be that the landmarks are far away, and then you want to have the luxury of seeing the site closely, but also seeing the distant landmarks. Okay, that's almost all for the data collection. I'm going to explain how you can actually change the menu so that it's not so sparse and too large. So basically, the reason for that event happening, that you have very large gaps in between these, is because different screens have different resolutions. The standard desktop is 96 dpi, but tablet computers, those have more points crammed into 1 inch. So the screen resolution is different, or the screen DPI to be more precisely. We've included the interface files for 2 different situations. So let's close that. Now the question is, do you want to save? Well, yeah, you can save. That's for the container file. Right. The UI files are the ones that control the layout of these forms. And the BBAT tool has been programmed to use the file named 1_conditions UI and 2_data UI. So these files need to be present. For the purpose of this demonstration, I'll change the names. Okay, and now these 2 files are actually 2 versions of this same user form. So one is a little bit more sparse for high resolution screens, and the other one is meant for the lower resolution screens or standard screens, so 96 dpi. So all you need to do is, well, this video is being recorded on standard screen, so I'll rename that just by deleting the suffix. And the same for the second file as well. So I'll delete the end. And that's it. We'll launch the tool again. And now you can probably see that it's more compact. And you can change also the size of the window itself. Right, a little bit more comfortable. It can also happen that you have change the UI to this 96 dpi screen option. And then if you deploy that tool on a tablet screen with higher resolution of DPI screen, then you will have it too cramped. So that's an indication that you need to go back and use the high screen DPI file instead. Let's go into the behavior data file and see what's actually happening there. Turn off the edit mode. You can press F6 on your regular desktop computer, or you can go through the menus, layer, open attribute table. So gender, age group, activity is null because it's the on-foot activity that we didn't enter. We entered the sports activity. So ball games is what got recorded. And then we have a whole bunch of switches here. So secondary activities are marked as 0s and 1s. So if you check mark that the person was resting, then that number will be 1 instead of 0. And that's helpful for analysis. You can export that attribute table into Excel, and you can, for instance, count how many points within your observation were involved in one or the other activity. Over here we said the first goalkeeper was spending his time also drinking a can of soda. Here it is. The weather data, as I said, if you remember to enter the data for weather parameters in the beginning, then that gets copied into that file. So every single record is a complete record. All the data is in that file, and every record contains all the weather information. Another very interesting thing that may be helpful for you is a timestamp. It's not visible when observers are entering the data, but actually a timestamp is recorded as well, so you can actually determine what time the data was entered. That's helpful, for instance, for payroll calculations, if you are employing the observers. You can look at how much time they spent on the site, and then maybe add some extra minutes for the other tasks that they would also need to be doing. Okay. So let's pretend that the observation has ended. Everything is done. Then the shapefile is saved. The edit mode has been turned off. You can exit the QGIS. And as I described already at least twice, all of these files are part of the observation for that particular day. So you need to compress the folder, send to compressed folder, and now it's one little package. If you look at the size, it's very small. You can send it over the email. So the observers doing the observations with their tablets later on in the evening when they're home and in the Wi-Fi range, they can compress the folder and send you the zip file. It's actually not necessary to have everything, because the data that you're interested is actually encapsulated in these files. As I said, if you enter the data for weather in the beginning, then that data is also automatically copied into that file, so actually you don't need the rest. But it's much easier to ask somebody to zip the whole folder and send it over, because it's just very, very small. Now, lastly, let's go over sample data. You've done your observations. Let's pretend you have, well, not pretend, let's say you have 30 different observations on the area. Sometimes it makes sense to have all these observations in separate folders, but quite often you want to merge the data together so that it's one single large database that you can start playing around. So how do you do that? You can go to the seed folder that you have prepared and make a copy of it and launch again the behavior mapping. Why you're using that is that you're having the same map layout that you've already prepared. All the orthophotos are there, all the vector files are there. You don't need to worry about the layout of the base map. And well, you will need to add all the observations to this file. So the way you do it is we've turned off this toolbar, so let's enable it back. View, toolbars, manage layers, and I'll put it back in. So you're adding vector layers, and the points are in vector layer. Browse. Now you need to browse to where you have saved these zip files. You need to extract them and go into them, and basically start adding them. So if you click inside the folder, it's filtering for Esri shapefiles, and you want this data shapefile. Open and open again, and it gets added to wherever QGIS thinks it's appropriate. So let's get rid of these two. Start from scratch. Yeah, and then you can drag it to the group. Continue. Add. Browse. And now you're in a wrong folder, so you need to go up and remember which folder you have already added. Go into next. Same file names, so that's slightly an issue, but they are living in different folders. You just need to keep track of what you have added. Again. And the last. Right, so we've imported all of our sample data. I've included 4 observations and they are actually not complete observations. I made a random selection of points from the original data. So of course you can turn on the layers one by one. That's sometimes helpful. But let's try and merge all of these 4 files into one database. How do you do that? Vector, data management tools, and merge vector layers. You want to merge vector layers. Now, layers to merge, they are displayed here in the order that they are also listed in the layers panel. So we want to select these 4 that we just added. Okay, 4 elements. And you can already say a new file name for that. New generated file that will merge the 4 observation campaigns, but actually we will need to do some more things to the data, so I will opt for temporary layer, and I want to have this check mark, so open output file, run. Right, so it's titled merged, so all this data has been merged into that file. When we were merging, you might have noticed that the projection EPSG was in Universal WGS84 projection system. That's not a very good projection system for analysis. So you want to have it changed to whatever is relevant to your location. But please do not change it here. That's not the place for changing the projection. What we want to do is save that merged data. So right click, save as, and then here we can give it a new name and also mark the relevant projection system, so we can reproject it into something else. So let's name it Tallinn BBAT 2019. And let's change that to the Estonian Lambert Est 97 coordinate system. Okay. And now that file is added to the layers list. And so actually we can throw away that data. That's not necessary anymore. You can click remove, and that is the whole data that we've added. Double click to change the display style, so something more visible, or maybe blue color. Right. sometimes it can be because of some bugs that are introduced in QGIS, or some bugs that are introduced in the data collection phase. These shapefiles start to behave weirdly. So when you save the file and export it to or try to use that file in another GIS program, you may have a failure. That's actually easy to fix. There's a facility for that, and I'll show you how to do it now. You need to have the tool panel, toolbox panel on. So here you can type in v.clean. It's a module that is installed as GRASS package. GRASS is another GIS software, and that gets installed along with the QGIS. If it's not enabled, look into settings. You can Google and find out how to enable GRASS in QGIS. You want to use the v.clean facility. Here in that menu, you want to select the file that you want to clean. So we want to clean the Tallinn BBAT 2019. And struggling to find where it is. It's in alphabetical order. Here it is. And basically any selection here, but I'll choose break as the cleaning tool. The threshold, let's say it's 1 centimeter. And then again we can save that as a temporary file. Run. Okay. So the vclean module has created 2 new files, errors. That usually contains absolutely nothing. So we can get rid of that. And now the cleaned data, that's actually the data that you're after. So actually we can remove the file and save that file. In projection 3301, and the file name, let's give it another file name. That cleaning I learned the hard way. I was pulling my hair sometimes, trying to figure out what the hell is going wrong. Why is this analysis not working, or why is this tool not working? Right. So now we have the cleaned shapefile containing 4 observations. Here we have all of these points in the table. And you can do very, very many things with that, and you learn more and more as you go along. But just to get you started, right click, filter, and you can start writing mathematical expressions to filter out the data. For instance, show me gender sample. So double click on gender equals female, double click, Okay. Some of the dots have disappeared. Now only the data for females is being shown. The filtering can be very elaborate. You can construct multiple filters. So let's say show me by gender female and age group equals 1 is the youngest, 4 is the oldest. So let's say the oldest age group. Okay, and now we are only seeing the points that are containing the data for older female users of the area in 4 different observations. You can also clear, let's say you're only interested in swimming. Let's say in water sample, yeah, in water equals bathing and dipping. Double click. Okay. So only that activity is being shown. Or you can say, let's see where the sunbathers are. Sunbathing equals 1. Aha. Not all sunbathers are on the sandy beach. Oh, that's obvious, but well, maybe not so obvious if you are into these cliches. Of course, majority of the sunbathing is happening on the sand, but not all of it. And now you can start looking into the questions like why. If it's good, then yeah, why not? What are the landscape factors around that? What are the affordances? And so on and so on. Thank you for bearing with me. It's been a very long instruction video on what you can do with the BBAT and how you can set it up. I hope this video has been helpful. As a final note, if you find that this tool is worth using and you would like to use that tool in your research or professional work, please be so kind as to reference our work. And that's it. Thank you.